technological and industrial capacities now and in the future. First of all, let me tell that our first guest, João Costeira, will arrive in a few minutes, so we'll start.
To everybody. First of all, apologize, as Mr. Vasco Trigo said, Adelino Matos is not possible to be here with us. I'm representing him, and I'll try to represent him as much as possible. Also, I'll try to be as most efficient as possible, because after lunch is every time a hard time to speak. So basically, I'm here representing ISCM Industries, which is the subholding of ISCM Group for the renewables and offshore activities. And we'll give a brief idea about the challenges basically that the metalworking industry have in Portugal to move on the offshore renewables. So roughly about the group, I assume most of you knows already ISCM Group, but for who doesn't know, ISCM is a group with 35 years old, founded in 1980 by Adelino de Silva Matos. It's currently a group composed by 20 different companies, 7 different fabrication facilities. I'm sorry. With more than 350 committed people, exporting mostly of its production worldwide, and the group is basically acting in the steel sector. So right now and today we are divided in 3 different and independent business units. One is our oil and gas business unit, another one is the logistic and the transportation, and ISCM Industries is the one I'm representing and is leading the heavy steel fabrication, both for onshore and offshore applications. So basically how we are organized in ISCM Industries, we have our core activity, which is the pure fabrication, and then we have a non-core activity, which is a strategic arm. We have to invest in technologies that can warrant to us future works in terms of steel works. A good example in this regard, this company is our shareholder position in Principal Power. We are proud to be the first institutional investors in the technology back in 2009, 2008. And so this is a good example that ISCM is able and willing to invest if we see that we can warrant, with of course the risk that we have in all these investments, if we see we can warrant future works, as the wind float is a good example. Some products we made in our facilities, basically wind towers, ring foundations, also some piles and some tubular components for offshore application. And as described already in the morning by Pedro Valverde, ISCM is a partner of the wind float. Here you see some pieces that were made in our facilities, the pre-components that then was shipped to Lisnav, where we performed the final assembly works. And we have, I would say, 2 key locations and 1 strategic partner or partnership location, let's say. One is our main facilities and headquarters in Severo do Volga, close to Aveiro city. Then we have Aveiro Port, is a logistics hub for us, but also it's an important place where we intend to invest in a new facility in the next couple of years. And also we have, there is Lisnav shipyard, as you may know, is one of the major shipyards in Europe, with great conditions to perform some final assembly works. And ISCM used Lisnav for the first wind float, and we hope to use also Lisnav for the next projects, which mean that we can warrant good projects, and we can also expand our activities to Lisnav, because it's a great location to perform complex and assembly works. Our facility right now, fully operational since 2006. It's part also, or it was created back in 2006 following the Wind Portuguese cluster, NEOP. So in the first years of operation, we produced towers for the Portuguese territory. Since 2011, we have been exporting all our towers worldwide, mostly in Europe, but also in Latin America. We have an upgrade that we are running now and will be ready in half a year, which will increase our capacity response, both for onshore towers, but also for some offshore components. Then we have, there is Lisnav. It's not, of course, our yard. It's a private yard, but it's where we have a good and open relationship with Lisnav management, and in where we can use part of this area, which was used on the old times for the ship construction. As Lisnav now is focused only on ship repair, there is an opportunity and a space to use for perform final assembly works, which is, in our opinion, a very suitable place if you think in a medium, long-term perspective. It gives us, of course, lots of flexibility for storage, for final assembly, and for load-out operations as well. Then we have Aveiro Port. It's a port where there is land available for industrial activities. We are moving on for a project for a new facility. We hope to be ready middle of 2017. And this is another commitment of ISCM in Portugal. So we will invest in a new facility to be able to answer in a more competitive way for the offshore industry. When we talk about offshore, we talk about logistics, we talk about constraints. I mean, we should be coast front located, otherwise we lose competitiveness. In fact, Aveiro Port is one of the only places in Portugal where we can have a coast front located facility without facing any constraint. I mean, a rentable, a tunnel, a bridge, and so we choose Aveiro for this, also for this particularity. Our experience in the offshore renewables, based mainly in Portugal. So Wave Roller, I believe that there is here people representing Wave Roller that will talk more about. We have just a small participation in this project. We basically supply the 6 floaters for this project, which is deployed in Peniche. Then our big participation was on the first wind float, the wind float 1. So it was a structure, I believe Pedro explained very well in the beginning, in the morning, what is exactly the wind float 1. So ISCM was leading all the fabrication, the components that were made in our facility, as you see previously, and then the final assembly works performed in Lisnav inside of the dry dock. This was a very important and anchor project for us because it gave us the due experience and the due know-how in the offshore. Is not the same work to offshore than work for onshore, of course. And it's a very nice business card for us to try to now to move on and to increase our activities in the offshore sector, worldwide and mostly in Europe, of course. So there is not much to talk about after the explanation of Pedro in the morning. So we are part of the consortium and we are proud to be part of this consortium, of course. Some pictures about the fabrication, the connection of all the pieces in the dry dock. And now I have just a small video, which I hope it works. Okay, this was just a small video made by Principal Power about it's a construction time lapse, 2 minutes, just to you to have an idea how we construct. So we build all the pre-fabrication. To Lisnav, we finalize the prefabrication outside of the dry dock. Then we move the columns, as Pedro said in the morning, and then we joint everything.
Something new is going to happen. The most natural thing, but nothing we'd expect. All these buildings and mountains, slowly they'll arise before our eyes.
Working day and the night. It was very challenging because we have a really short time to move out the platform.
How do cities understand? We drink our wine and wonder why we're really here. What's the point of even asking? You take the good and bad and make the best of it. All these buildings and mountains.
So let's keep it offshore renewables in Europe. I will not take too much time in these slides. We all know about the potential of the offshore renewables in Europe. Either offshore wind, this is a scenario made by European Wind Energy Association last year, which proves if we really only look for the medium scenario, it's already a big potential that will come online in Europe over the next years. When we talk about tidal and wave, there is also a big potential for Europe and for the world. And when we talk about these offshore solutions and technologies, of course, the concrete will also have a good role, but still is the major component and the major raw material to be used. So there is lots of potentiality for the supply chain. I will take a little bit more fast. The potentiality in Europe, of course, there is more mature technologies than the other ones. ISCM looks more into offshore wind as is a more commercial technology that can warrant us the due scalability. It's important to have an idea about how the industry is organized. I believe Mr. João Costeira can give us more details about the approach of EDP as main contractor in this industry, because we need to know how this is organized to position ourselves in the supply chain. Then Portugal is ready. This is, I think, the big question for us. We would say that it's partly ready, but it needs to work hardly over the next years. We have a long coast. We have a pilot zone already. We have the POM ongoing. We have a huge exclusivity zone. We have shipyards. We have ports. Even if they are not the biggest ones, we have already the infrastructures. We have a metal industry very competitive and very heavy on the economy of the Portugal, which is very important when we talk about offshore energy. We talk about driving the cost down, so competitiveness is a key word. We have a success case, and open. We have international companies. The big challenges now ending for the Portuguese industry. I would say that we should be organized, have common vision and goals. I mean, cooperation rather than cannibalization, I think, is the goal. Structure the supply chain, each company in each place. Verticalize as much as possible the solution offered in order to create add value. If we put all this together and synchronize it, we certainly will be able to attend big and complex projects in a competitive way. I mean, we, Portuguese industry, all together. The message is the union and not each one for each side. When we talk about fabrication steelworks, we talk about contracting and complex contracts with high risk. So we should warrant that we have the specialized training, and these are already some challenges that the Portuguese industry must be aware. We need also to warrant the due machinery, the due engineering, and the due process. For instance, automatic process, welding process are very important to reduce the costs. Risk sharing is a very important factor in this industry. The logistics, the insurance, the financing, I mean, all this is very important to be all synchronized, otherwise there is no way to move on. When we talk about joint skills, and when we talk about an offshore project, we talk about primary steel, we talk about secondary steel, we talk about coating, assembly, special works, we talk about design, engineering, optimization, to reduce costs, electrical and instrumentation, logistics and service. So there is a wide range of activities that must be all together in order to be able to attend in a competitive way an offshore project. Finalizing and talking about the infrastructures and the current facilities in Portugal. We know that there is need to adjust some of them and to improve some of them, but also to invest in some of them, rather if it's public or private investment. Where the yards and the shipyards, they should be we should adapt their tools, their skills, of course, for the ones that gives priority to the offshore renewables, because the shipyards have also other priorities to move on. The ports, we need to warrant water depths to host big ships, to carry big cargo. Dragage channels, of course, very, very important, and the capacity of the quay and the dimensions to load big components also. Public authorities is also very important to be aligned with this industry. Just to give you an example, I told you in the beginning we are moving on for an upgrade of our facilities, which we expect to invest roughly 3.5–4 million euros. We find out last week that there is a road passing just above our facility, which is very strange, and we are now blocked by the Portuguese authorities because no one knows why there is a way passing through our facility, but also no one knows how to deblock the situation. So there is an example, a company that wants to invest and is now stopped waiting for a decision that someone took without any sense. Roads and railways are also very important when you talk about the logistics. We need to have free access with as less constraints as possible to the major ports and to the major hubs. And so I'm finalizing. Portugal can have a big role in Europe. We are not in the corner. Even if we are in the corner of Europe, we are not far away for the big points. These words are very important to keep in mind when we want to go to the offshore market, and driving the cost down is the rule. So we have facilities, we have skilled people, we have very recognized companies in Portugal. We just need to put it all together to be competitive and to give an appropriate response. So thank you very much for your time, and I'm here to answer any questions.
Well, I guess what I can do maybe is, while this starts, and I could briefly make you a presentation of the company. I think that most of you at least have heard of us. Some of you are even unlucky enough to be our customers. But EDP, the company I work for, is the biggest Portuguese company, vertically integrated and in more than 14 countries, and by far the largest Portuguese industrial group, and with a credit rating which is above the Portuguese Republic, which right now is not fantastic, but still it's relevant. We have worldwide 22 gigawatts installed, almost 12,000 people working for us, and we generate a yearly EBIT of 3.6 billion and a net profit of around 1 billion. Within EDP, and for the last 8 years now, renewables have been, I would say, the most relevant business and the main engine of growth. Right now, renewables, which does not include hydro, already accounts for 25% of the EBITDA and 49% of all investment over the last 7 years. This led to a relevant growth of the production, which has been from 2008 till 2014, growing at a compounded average growth rate of 17%, reaching in 2014 20 terawatts hour of energy produced, which makes us the 4th largest wind producer in the world. How does this spread over the global landscape? Our main market is right now, and will probably be even more in the future, the United States, where we have 4 gigawatts of energy of capacity installed, followed by Spain with 2.3 gigawatts and Portugal with 1.2. In Portugal, we are the biggest wind producer, and in Spain and the United States, our 2 key markets, we are the 3rd largest wind producer. Besides these 3 key markets, we are present in Poland, where we are the largest one, in Romania, we're the third, Italy, Belgium, Brazil, Canada, and also France, where we are the fifth largest producer with almost 400 megawatts operating. And I would deep dive a little bit on our French presence. Graphics would help, but again, the good thing is that I go faster like this. No, but basically, we entered the French market in 2006 with a small acquisition of a local developer, and then made two further acquisitions of mainly pipeline, which we've been developing ever since, and adding to that our own pipeline. Right now, we have, by year end, we shall have 400 megawatts operating, and we hope to reach 500 by the end of 2016. They are a little bit spread all over the place, but mainly in Brittany and Normandy, and also something around the Massif Central. This, the French market is particular in the sense that wind farms are very small. So to reach these kind of numbers, you have to have more than 30 wind farms operating. We have roughly 40 people working for us in France. And here I'm only talking about onshore. But what we have seen over the last few years is that there is, although markets can vary, notable slowdown of onshore projects in Europe, and basically due to line congestion, NIMBY effect, meaning that people love wind farms, they just don't want to see them. This is particularly true in France and the United Kingdom. And also by the fact that in some cases there is really not that much wind, at least in some countries, right? So if you bring that all together, one of the opportunities that was there in Europe, especially in the zone of the North Sea, and we'll see why, was offshore. Offshore wind, although it is more expensive to build, it has much less environmental impact, over the landscape, over, let's say, the life of people in general. And it has more wind resource. Wind in the sea blows more than onshore, that's for sure. And in part, this offsets the fact that the investment is higher. So if you bring this all together, the EDPR also decided to be present in offshore. Basically, we started with the round 3 in the UK in 2010, which was sort of a beauty contest that the British government organized to select companies who would be able to develop large wind farms. We won an area in North Scotland that we've been developing ever since. It's a lengthy process. And right now we have the permits to install up to 1 gigawatts on that area. Later, in 2012, we partnered up with what was then GDF Suez, now Engie, and Neoen, which is a company partly owned by Caisse des Dépôts et Consignations, to bid for the tender of 2 offshore zones in France, in Le Tréport and l'Île d'Yeu in Noirmoutier, which we won. And we are right now going under the de-risking phase, namely doing all the geophysical studies, interconnection studies, environmental studies, and we hope to have a decision on go ahead by mid next year. Finally, and on a more R&D landscape, EDP made the first deepwater offshore pilot that is installed in northern Portugal off the coast of Vienna, and which has been operating from 2011 so far with very good results. A little bit more information on our venture in the Moray Firth, which is northern Scotland. See it up here. This is a site that is fully owned by us, but for which we have already sold a stake the next few months to another investor. It will have turbines of up to 8 megawatts unitary capacity, which are the biggest ones that are right now. They exist. They don't even exist, but they will exist in the future. And we have all the key consents, so we are eligible to bid and win CFD, which is basically a power purchase agreement with a reasonably fixed price with the British state, with the British government, that should, in a tender that should take place next year. Hopefully we will win. It's a bid, so you never know, but it's the way it is. And the final investment decision should be taken 12 months after the bid award. The overall investment should be above 1.5 billion euros. In France, as I mentioned, there are two areas, Trigo and renewable. This one is near Nantes. It's here, and this one is on the northern coast, so it's facing the British Channel. These are two 500 megawatts wind farms, each of them with pretty much the same investment, 1.5 billion euros, and which have a relatively shallow waters. One of them, especially the Trigo, which is run from 10 to 30 meters, whereas in Lille it's between 30 and 40 meters. I forgot to mention that in Scotland the depths are between also 30 and 45 meters. So this is the basic characterization. We plan to have a final investment decision by 2018, and the commercial operation date should be in 2021. Okay. This is a brief description of the floating project. This is the why floating. It's more expensive, that's one thing, but especially there are only very few places on the planet where you can do not floating offshore, and those would be, as I mentioned, the North Sea and the Baltic Sea. Everywhere else, when you go off the coast, suddenly the depth increases dramatically, like in Portugal, you're 2 kilometers off the coast and you're already 200 meters depth, which makes it inviable for a traditional, let's say, fixed to the ground offshore. This is particularly important for countries such as Japan or Korea, or even the US, where this happens a lot, like it does in Portugal and in the part of the coast of Spain. I would skip the technical characteristics, but then we can come back to that if you have any particular question. And I would move to the supply chain part, especially what we can do what we've been doing both in Portugal and in Spain. EDPR, we have sort of a tradition of engaging with the supply chain, local supply chain. We did that so in a substantial way with the NL project, which was a 1.2 gigawatt project here in Portugal, which created 1.7 thousand direct jobs and more than 3,000 indirect jobs, and involved all these companies that you see here, that from Solidal, Cabel, CME, Painhas, Enercon, of course, Montalgrua, Silva Matos. So all those companies were involved, Jaime da Costa, and this is the result of a very important investment that we participated in. Something similar has been going on in onshore, in our developments in offshore, with Portuguese companies that we take with us abroad. These are just a few examples. In all the countries that we're in, you can see in Brazil, Romania, Spain, France, Poland. We have all these companies, Italy, all these companies working with us, FASEC, ISCTE-Instituto, Afaplan, Solidal, and I could go on, but I would skip you. I won't go into too much of a detail. But when it comes to offshore, I think this can be even more important. Only in the wind float demonstrator that we talked about, already we were able to bring together these companies, some of which historical ones in Portugal, like Lisnava, Silva Matos, Tegopi, Solidal, and we believe that this will become even more important if we proceed with the second phase, which would be a 30 megawatt offshore wind farm. Finally, also in France, and for what is the industrial plan, which would be associated with the two projects that we talked about. This is something that we did together with, initially it was Areva, which is a big French company that right now merged for the offshore business with a Spanish company, Gamesa, and formed this new venture, Adwen. And for these two projects, they will build 5 new factories at Le Havre, and 2 further for making the nacelles, blades, bearings, gearboxes, and generators, so the full turbine, plus 2 factories fabricating towers. And we already contacted more than 500 small and medium enterprises, French ones, that could also participate as, let's say, second line supply chain. This will create 6,000 jobs during construction, of which 1,500 will be direct and 4,500 indirect. And 500 jobs that will stay in this area for the full duration of the assets, which is estimated in 20 years. I won't bother you anymore. I think my time is up. Just wanted to give you an idea of, let's say, the externalities, the positive externalities that this kind of projects can have on local economy. Thank you very much.
Thank you for the invitation to speak about the shipbuilding and repair industry. Our association, I'm General Secretary of the association, and the presidency of the association belongs to Lisnav shipyards that has been referred so much this evening. Our main core is shipbuilding yards, but we have also in our association some engineering companies, investigation companies. ISCTE is our member, as well as Rebonav, that was already referred just before. Well, I would like to say and to answer just immediately to Ricardo in saying that the shipbuilding industry is present and is prepared to answer to the needs of the offshore demand, and particularly on this area on the renewable energy, floating renewable energy, marine renewable energies. Well, I would say the offshore wind will play a significant role in the future energy mix, as has been said during the... Well, thank you. Well, first a few words about the development of the demand. Offshore energy, according the European Wind Energy Association, the capacity will grow from the existing 5 gigawatts you are now to 150 by 2030. That's meeting 40% of the EU's total electricity consumption. Offshore wind farms are being built further from the coast and in deeper waters to harness better wind resources. Average project size has also increased significantly, as typical size has grown from 60 to 300 megawatts. Today, new offshore designs and personal skills and competences are needed to explore huge resources of North Sea, Atlantic and Mediterranean deep waters for water depths greater than 50 meters. I'm just, it's not much visible on, but according, I've been working what a consultant, Douglas Westwood, on the project he has done to OECD, regarding reorientation of shipyards opportunities and offshore energy. And here you can see, oh, sorry. No. go for... Well, on the graph before, we could see that the evolution just to show this graph, this is the expected evolution of the demand of offshore wind, and that is the other part is the wave. That means it is expected to have a very strong, almost exponential demand for the offshore industry. Well, here you can see on this graph what is the number of vessels required for the period between 2014 and 2025. That means that will range from 1,229 units to 1,964 units. And the important to see is the bigger requirement is for the offshore supply vessels. And that's here where our shipyards, our shipbuilding yards could give a big answer and contributing to the demand of this, to the big demand that is going to happen on that area for the offshore vessels. Almost our largest shipyards, Viana do Castelo, West Sea, also the shipyard in Mondego shipyards, the Atlantic Eagle Shipbuilding, as well as Indústrias Navais de Peniche, are ready to answer to this kind of market. Well, here we can see also the evolution, in that same graph we can see the conclusions of work that has been done from European Economic and Social Committee to the EU Commission. And they say that it is expected that the growth will be about 3.7% annually between now and 2025. That means it is expected a big demand on that area. Well, on this slide, it's interesting to see because it's very similar with as happened on shipbuilding industry. We can see here is the demand for offshore vessels, and the demand is as a function of price of oil. And on the beginning of decade on 1970, the growth has been, the price of oil has increased very much till 20, what gives origin to a big demand on offshore vessels. Well, that decreased decade afterwards. And on the last decade, we have seen again a last increase. And this increase is as provoked by the renewal, by new, for replacing part of this offshore, of this fleet, and also for new demands. Well, now we are on a critical point, as I will show you just immediately. Well, we can see the driver, the price of oil, as I've said. This is another, from another source, from Europe, and his market forecast report for 2015 has presented this graph where is demand for and the production for offshore vessels and also the price of oil. Is what is also forecast for the energy consumption. Again, we can see from the renewables, renewables energy is the growing is on that source. The increase is 5%. On the other source, we have seen that was around 3.5. Well, these figures are this shows the actual situation what we are living now. Some shipyards in the north in Norway are just closing or having very big difficulties, and the market is bad for that area. And the reason is we can see the number of vessels contracted according to Clarkson's research. The publication they produced last week, that means we have figures for the 1st November of 2015. You can see that the offshore vessels, the contracting number, has reduced from 448 in 2014 for 29 on 2015, on the 1st November. And also the floating production and storage units, as floating storage units, are this year only one unit has been contracted. That means this, but is not, there is all experts say, well, this is that the situation that we are living now? For sure, we'll not keep having these figures, and every people says, and I believe that it is true, that the price of crude oil will increase in the near future. And that means the demand will again increase very much. Well, now I'm coming to the reason of my presentation is the training qualification that just before has been referred, Ricardo has referred. The shipyards have need to increase their capabilities, their quality, and this, in fact, a study that is also that has been produced, where is constating that there are shortage of supply of manpower supply. The offshore, the global offshore. Well, this there is a shortage according the EU Wind Energy Technology Platform. They said there is a deficit of 5,000. Oh, again, I jumped. Of deficit of that doesn't matter. Shortage of 5,000 appropriately qualified personnel, which may increase to 18,000 by 2030. That means that industry are going to need a lot of qualified people to act in this sector. The industry has a knowledge that there will need to be a drive towards recruiting and training suitable skilled personnel to carry out the work required to meet the global wind farm energy. Anyway, the qualification given must be, when possible, classified by ESCO, the multilingual classification of European skills, competencies, qualifications, and occupations, as well at national level by national catalog qualification. This is important because all the workers that have an education should have a certification in order to allow more transparency and competencies produced and known. Well, this is coming. The Portuguese shipyards have already already gave a contribution to this market. Well, as has been referred here, the work made at shipyard. The shipyard has made assembling, but also these supports of the columns have been constructed on the site of Lisboa premises. That means that where some problems were detected regarding the quality and the organization of work, but this is and will be very easily done. Well, you can see as has been shown in different photos. Well, I like that you are not spoken so much regarding the work that has been done at Instalações Navais de Peniche. Well, in Instalações Navais de Peniche, where was mounted the wave roller plant. Well, wave roller, he has been already moving to the place where he's been immersed. And it was important to say that some part of the barge has been done on the shipyard, and also these flaps that originally were made in fiberglass and were being removed and renewed by a new one that the system now is only with one flap, by one made in steel, and no special work was needed to the shipyard works to perform the work. Well, they need to be the welders have to be classified, and some preparation has to be done, some more. But the industry is capable to answer to the demands of new building. Well, of course, it is important to say all this again. It's important to say that these columns that have been made by Silva Matos, and we need shipyards could complement the work in addition of these metal industry firms, because they have experience on producing these large pipes with large thickness, where special requirements have to be done by the welding, and sometimes being needed to buy very expensive machines, welding automatic machines that will perform the work. That means shipyards are prepared to give some support to the specialists, to the metal, to the industry on producing these equipments. Well, just last words to see that to ensure the sustainability and development of the European offshore industry, it is needed a coherent strategic vision, providing advanced technologies and innovative solutions. A knowledge of relations between offshore and maritime industry confirms that offshore industry is a strong driver for maritime industry, particularly for shipbuilding, repair, and equipment sectors. Considering the shortage of qualified workers and skills in offshore industry, it is recommended new policies for adapting skills and training and encouraging young people to work at sea. Europe 2020 strategy should be updated to meet the EU requirements relating to maritime activities and financing and promoting sustainable development, bearing in mind the wide range and variety of types of work and skills that are necessary in the area of offshore. Thank you.
Thank you very much.
Well, as said, I'm Marc Lazzaretto. I work for the Port of Marseille Fos, and I develop industrial and logistic plants within the port. Oh, there it is. So, I was asked to talk about energy issues at the Port of Marseille Fos, so I'll talk, of course, of the Port of Marseille Fos, but I think we can extend our reflection within Marseille Fos to other ports. And the fact that I'm the only port representative today is perhaps an example of the port issue that is underestimated. So I give you a quick overview of the Port of Marseille. Then we shall talk quickly about fossil energies, and that brings us to energy transition. And the reason I'm here today, speaking about energy efficiency and renewable energy production. And finally, the EOS project, which is just what we're doing to contribute to the renewable energy production industry in development in France. So Marseille Fos is one port, two harbors. It's the traditional port, city port in the city of Marseille. That's 400 hectares enclosed in town center. What we're talking, generally when we're talking of the port of Marseille Fos, is the Fos area. That's 10,000 hectares. Just to give you an idea, fortunately the circumstances aren't very happy, but it's the equivalent of the city of Paris. This is the ground this is my playground. So what we love to do at port is to add dry bulk with liquid bulk and containers. And when we do that, we reach a global traffic of 80 million tons, which makes of the port of Marseille Fos the first port of France. Doesn't mean much, but it's the figures. We have over 8,000 ship calls a year for gross product of 140 million. What's more interesting is that we employ 1,000 people working for the port, but we employ indirectly more than 40,000 jobs. And a great part of these jobs are from industry, are for the industry. You may notice that most volumes are up. So we're very proud of that. And one is down. The one is down represents 50% of our business in volume. That's liquid bulk, of which mainly is crude oil. And that's a tender that's been going on since 2008. Since 2008, crude oil has dropped by something like 20 million tons. And that's a 40% drop. So it's not something new, it's something that we had foreseen. And we had foreseen relays of growth with LNG. Unfortunately, what we hadn't foreseen was the Fukushima disaster and the shale gas in the States, which changed all the LNG worldwide market. And we are now looking into new relays of growth for energy, and energy transition is potential and very important for us and for the region, because this is something new. As I said, we count volumes and we earn our money by volumes going through the port. Energy transition means thinking the business model over. Oh, this one said in French, but to make sure that it's a serious topic, we wrote it in the strategic project of the port. French ports have to elaborate a strategic project for a period of 5 years. Ours is based on 4 topics, and the 4th topic is to be an actor of the energy transition with the territories we live in, and to develop employment. I put in red something that concerns us directly today. So it's in French, I'm sorry, but what we intend to be is to be an engine of the transition, of energy transition, and to promote energy production based on renewable energies. So, 2 laboratories, if we can call it so, the first one is energy efficiency. PICTO project, which is a marketing claim for an industrial and innovative platform of Cabantonquin. That's the name of the place. I go fast. What is it? Just to make things short, it's 1,200 hectares dedicated to industry, within which 12 hectares are dedicated to innovation. And one important thing here is that we bring and implant on this site demonstrators. One of our demonstrators is to convert CO2, which is produced mainly within the industries locally, into CH4 with the adding of H2. That's if you remember your chemical lectures. The question is, where does the H2 come? Where does the hydrogen come? The hydrogen comes from the sea using electricity. Where does the electricity come from? Well, the electricity could come from renewable energy when the grid, the electrical grid or network, isn't in demand of electricity. That's where things interconnect. Now you're going to ask me, where do you produce this renewable electric source? Where do you produce the renewable electricity? Well, oh, sorry. I go fast. Well, we produce it on different parts of the port. We have photovoltaic, we have onshore wind turbines. What's in blue exists already. It's partly in French. But we've already developed, we covered all our warehouses, or we're covering our warehouses with photovoltaic panels. We have also wind turbines. But tomorrow, we're looking to the sea. It might sound curious, but it took us time to look at the sea as a port, but that's what we're doing actually. In Marseille is undergoing a great refurbishing, and they're transforming all the warehouses in the city center into buildings. All these buildings, a lot of buildings, have used in cooling and heating system with the exchanging heat with the seawater of the port, within the port. And, what we've been talking since this morning, a source of electricity is, of course, the pilot floating offshore wind farms. Now, EDF, which is the French national company, has developed a zone to pilot wind farms, and the government has published this summer a request for proposal to develop pilot wind farms in the Mediterranean Sea, mostly. We're going to see this. So what is the request for proposal that the government has launched? You all seen this picture. I've already seen it twice, I think, since this morning, of how there's so much wind in Scotland and in the large, and just off the French coast in the Mediterranean. What's more interesting is that there's a 3 gigawatts estimated that could be generated in the southern zone, which today means something like 300, 400 wind turbines. The request of proposal is an envelope that the government is putting out of 150 million plus a cost of buyback electricity for 4 zones with 3 in the Med. So the 3 in the Med we shall see after where they are. It's 3 to 6 floating wind turbines of a minimum of 5 megawatts each. And the schedule is the one you see below. The first line is, no, oops, back. Where's the point? There. So the request for proposal was published this summer, and you have until the 4th of April 2016 to reply. The government said that they'll give the names of the winners very soon, before summer, probably September, knowing them how they work. Which means that we shall see floating objects around about 2020. Hopefully, and I'm not talking for myself, but for different organizations, we hope to see the publication of a tender for commercial firms as from 2018, perhaps 2020, this period here. These 2 schedules are, the overlapping of these 2 schedules are very important, because as we're going to see, here we're talking about 3 to 6 wind turbines to be constructed, assembled, and put on zone. And here we're talking perhaps of 100 or more, perhaps. This schedule here is not is just an idea, a shared idea. This will condition the creation of a new industry, and we hope to take part in this new industry as a port. And that's the project which we name EOS here. Is developing a new port industry, because I believe that we're not talking about casual shipbuilding. We're talking about floating objects that are going to weigh something between 2,000 and 8,000 tons, dimension over 200 meters high. And as far as I know, there's not many ports, if none, in the Mediterranean who are able, who are capable of receiving such objects. Anyway, perhaps one, but making an industry as based in a port or through a port seems very difficult. So we looked into the main functions and key parameters. For us, there's 3 functions that need to go through a port. It can be the port where we construct floaters, because floaters are the main hard point in the development of floating offshore wind farms. This can be shipyards. It doesn't have to be a shipyard. There's assembling the turbine, the mast on the floater, And then there's the logistic of maintenance, bringing the ship, the floater out to sea, bringing it back when it needs maintenance, perhaps, if it needs repair. So these are three functions that we are going to, what we imagine going through ports and allowing ports to build a new business model from. You can't, port-wise, you can't consider a floating wind turbine as just a high and heavy parcel. It's more than that. As you know, weight can go up to 8,000 tons, perhaps more. It needs place, and that's not the least to say. We estimate that to build between 3 and 6 wind turbines, we need between 2 and 6 hectares. It needs draft between 6 and 10 meters, following what you're talking. And it needs berth length, or quayside, between 100 and 200 meters. This is just to illustrate. It doesn't necessarily live very well with other activities. And you also have to have the know-how to use haulage at this size. 3 minutes, okay. Infrastructures, just to make things, just to fix some ideas. Infrastructures mainly range between 4 and 10 tons per square meters. When we're talking about the super high and heavy for the floating wind turbines, we're talking about at least 15 tons square meters, if not 20, ideally 25 or 30. It's not common. It needs reinforcement, major investments. Shipyards. This is in Marseille city. We have the chance with the luck to have what we call Dock 10. It's 450 meters long, 80 meters wide. There's 2 of them in the Mediterranean, one here and one in Palermo. They're not dedicated to building floating windmills. They can do 1, they can do 2, and they're certainly not foreseen to build a series of more. So we need to adapt. We need surface. We imagine, here in Marseille, or in Fos actually, we can give 4 hectares here, another 6 here, and then we can even foresee 100 square hectares here behind it, if the industry develops from Marseille. There's also key parameters. We need to talk about vessel accessibility. We need sheltered harbors. That's quite common. Tide isn't no tide, because when you go up and down, it's not very easy to fix a mast. No air drafts. We're talking about something like 200 meters high. You'll be surprised of how much radar control can limit air draft. We need road accessibility. We need proximity to site. And we need industrial environment. Here, I'm not going to sell my thing more than necessary. Where no tide, direct access to sea, all connected with rail, road, and river. The 3 zones in Mediterranean for the request are the one here just out of Marseille, 117 square kilos. Oh, sorry. You got the idea. 11 nautical miles. 2 more here on the eastern coast or western coast of the French Mediterranean Sea. The industrial environment. This is a very important point. When you produce electricity, you have to feed it into the grid. You need the connections, very expensive. As you can see on the border, this is the French connection on the seaside. The only 400 kilowatts volt network is here in Marseille, double connection. You need skilled workforces, and you need industrial plants. You need steel you need steel companies, metallic constructions, you need shipyards, and you need numerous subcontractors specialized in coating, welding, electrical engineering. So I'm going to go fast. So just to finish, hopefully in time, new industry, for us it's a new industry. It's new volumes, which means a new business plan. And this means making suitable port infrastructures. We don't think that today any port is capable of meeting the requests that developers have. And to conclude on synthesis reward, our task is not to foresee the future, but to enable it.
Thank you very much.
Everyone. So I've been working for Mojo for 4 years now, and recently came back to France last year to open a new subsidiary in France. So I'm going to talk to you about Mermaid, which is a planning software for marine operation. Mermaid stands for Marine Economic Risk Management Aid. So first, I'm going to give you an overview of the company. So what we do is basically we do all the marine operations to install assets at sea. So we will charter vessels, we put a team on the vessels, we manage all the operation at sea. And we also do all the planning in-house. And we've got both teams in the same offices, both in England and in France. And our main core of activities are in the marine renewables, so wind and wave, and especially most important one is tide. So historically, the company started as a local company in Cornwall in the UK, dealing with telecom cables. In 2010, we started the software Mermaid, which is coming from a PhD program with the University of Exeter and Mojo Maritime. Then there's been few more investments to develop the software a bit more. And 3 years, so in about 2013, we were able to use the software internally for clients, so for real projects. In 2014, we created the French subsidiary. So we are now 3 people working in France, knowing that the UK offices, there are about 30 people. So half and half are in the office doing the engineering studies, and the other half is going offshore, basically. And you've probably heard that in 2015, we've been acquired by a larger company called James Fisher & Sons, which is more or less an equivalent of the DCNS. The only difference is that DCNS, in terms of, it's got public investment, and James Fisher is a private company. So basically where we are based, so the headquarters of Mojo Maritime is in Falmouth, in Cornwall. Then James Fisher & Sons, they've got many offices in the UK. The headquarters of the French subsidiary is in Cherbourg, as we are very interested in taking part of the installation of the tidal farms, the pilot tidal farms to start with, and then the commercial tidal farms in the Ras Blanchard. And we've got an office in Nantes, where I'm based, basically. Then our capabilities, so in terms of marine operations, so while I'm talking to you now, I've got all my colleagues on the vessels in Wales installing a tidal device. What we've also done is installing the 4 cables at the Mermaid site in Scotland. So I'm sure you've heard about. So I don't know if I... So basically that's the vessels, the same Dia one that we've chartered. The one on the right is a wave energy device that we've installed in the south of the UK. Called Polygen, and at the bottom is the voice turbine installation, where we've basically been doing all of the work, going from the export cable to installing the monopile, developing a subsea drilling foundation with Bauer, doing the operation, installing the nacelle, installing the jumper cables, and connecting the device to the grid. So that was done at EMEC. So I've put some examples of our main clients. The other part is the engineering consultancy. So the one you can see was for, at the top, the pictures, the three pictures, were for the bower drilling tool. So we helped them developing the design of this tool, looking at the stability of the asset while he was drilling. So we did that with the help of Bauer. Obviously, we did that in 6 months, having the concept design and then having the asset on the key. We've also worked in the offshore wind, doing some studies for the aviation guidelines, for example. So now to basically give one of the possible answers to the question that was raised this morning for EDP and EDR about the reducing the risk and cost. Basically, how do we reduce risk and cost? One of the answers is this product, Mermaid, that I'm going to present to you. So basically, for floating wind, it's quite new technology. So as we've seen this morning, there's a couple that have been installed in here and in Scotland for the iWind, and even in Japan. But they are prototypes, so there's quite little experience about these devices. But we want to install commercial arrays quite quickly. So looking at the main operation is usually we tow the devices, the turbines at site, and then we anchor it with moorings. But these operations are very sensitive to weather conditions. So now the question, for a farm, how do we do that? How many vessels do we take? At what point the tow become reliable, and how we can parallelize the different operations? So the answer is that we need the tools that can allow us to look at this operation and give us an overview of where are the critical tasks and how we can optimize that, which is why we've developed the tool called Mermaid, where we can look at the port draft and put the various limits on the operations, on the vessels we are using, on the where we are, what sites, having the geographic coordinates, looking at the different transits, can the vessel transit with different wave heights, for example. So the tool Mermaid, so basically we took all the project specifications, so we discretize the project task per task, and we go down to the minute. We look at the different vessels, the different ports, and then we take hindcast metocean data. So the DNV is recommending to use more than 10 years of data. So usually we tend to use 20 years. And then we run that through Mermaid, and then it gives us an output of the length, of the duration of the overall operations. And then it tells us what task is the longest and the most limited by the metocean conditions. And then we can optimize it and run it again. So the main point of this is to run it basically before we go out at sea and fail. So it's better to fail in the office before rather than failing offshore. So this is just some screenshots of the user interface that we have developed. So at the top, you can have a look at the map chart, where you can see your, where are your turbines, where is your mobilization port, what transit, where you're going to go for your transit. And at the bottom, you have an example of the flow chart diagram. So I've got this software here, and for those who are interested, you can come to me and I can show you in real how the software is. So the advantage of the software is that we can run multiple cases, we can compare vessels, we can have simultaneous tasks, and then it tells us, and we run the project. For example, if we are to start the project in June, we can run it through different years or running through different months to have a look at the impact of starting the operation at this exact date. And then it tells us at what date we should start the project. So this is an example. So in here you can see that it's better to start the project in the summer, obviously. So that was done for an offshore wind project. And then we have an overview, an idea of what is the cost and duration. So depending on the steepness of the bottom curve, we can see what are the risks of cost escalation, for example. And we can see the impact of having bad years, the difference between a bad year and a good year. So this is it. So if you have any question, feel free to ask.